Welcome 4C and 4U chemistry students. This is the beginning of our last unit. So we're looking at electrochemistry, which as it sounds is chemistry involving electricity or moving electrons. So electrochemistry is important in the study of all batteries. It also has to do with corrosion, combustion, photosynthesis. And the reason all those things have something in common is they all do something called a redox reaction. So the redox reactions comes from two words, oxidation and reduction, and they've been combined into a little short form. And originally those names had something to do with if the weight of something got less, they called it reduction. And this was first used when metals were being isolated from compounds. So in the example here, copper in copper chloride is isolated into pure copper. So when that happens, the original mass of the copper chloride becomes less or was reduced. That is not the meaning of reduction anymore, but that's how it originated. So this is a reduction reaction here, or a redox reaction altogether. And we're going to come back to that and do an example using these equations. Here's another one, oxidation. Anytime something reacts with oxygen, we're going to have an oxidation reaction for sure. And primarily what you're going to see is that the element is going to become a compound. Okay. So today when you hear the term oxidation reduction or redox, literally what we are talking about is the transfer of electrons, because that is really what is happening. And because we transfer electrons during these chemical reactions, whatever electrons get lost by one element obviously have to get gained by the other, because we're not going to just lose them or destroy them. So oxidation reactions have, or the thing that gets oxidized, has a loss of electrons. So we have a little acronym here that can actually help you a little bit. So Leo the lion says GR. So when you lose electrons, you have oxidation. Okay. So, oops, I'm touching the wrong spot here. I was thinking something didn't seem right. There we go. So Leo is lose electrons is oxidation. And reduction, we are gaining electrons. So GR, that's better. Okay, so that's just a little thing that can help you remember what is going on with oxidation and reduction. So it's all about transferring electrons. Okay. So in order to analyze what has had electrons lost or gained, we have to check out its charge. So the same old ionic charges we've been looking at on the periodic table ever since you began studying chemistry. So if it's an ionic compound, which is made of metal and nonmetals, literally look up the charge on the periodic table. So in calcium fluoride, the ionic charge on calcium is +2 because it's found in group 2. And fluorine is typically -1, being as it's a halogen, but it might sometimes be something different. But the one way you can tell for sure is that the overall charge on your molecule would be 0. So the fact that we have +2 for calcium means fluorine has to be -1. Now, this works for ionic compounds, but there are lots and lots of molecular compounds with covalent bonds, and in that case, we're sharing electrons. So when we're sharing, we certainly don't call it an ionic charge because we haven't lost or gained electrons to have a full-out charge. So we call it an oxidation number instead, and the short form is ON. This is just a number that represents what the charge would be on the element if it wasn't sharing and it was actually losing or gaining. This would be its representative charge, but it's definitely sharing. So anything molecular or polyatomic ions, which are also molecular because they're all nonmetals, this is what we're going to be worrying about. So we can't just look that up on the periodic table the same. Now, either way, whether it's an ionic charge or an oxidation number, so ionic compounds, molecular, the one thing that always holds true is that if you're being oxidized, your oxidation number is going to become more positive. And that's because we said an oxidation is a loss of electrons. So if you lose some negative electrons, you should become more positive, okay? Because you are losing electrons. If you go the other way, you are gaining electrons, and your oxidation number should therefore become more negative. Okay. So you've watched a couple videos, and those videos have gone over some common oxidation number rules. So here I have summarized them, but all just pure elements, the oxidation number is just 0. And that's because it's not bonded to anything, or if it is diatomic like oxygen or fluorine or chlorine, it would be perfectly equally sharing. So the oxidation number is just 0. So notice phosphorus in P4 is also 0. For our purposes, hydrogen is always going to be +1. There are a couple of exceptions, and oxygen is always going to be -2. Again, there are a couple of exceptions, but nothing we're going to worry about this year. Now, monovalent metal ions, that is ions that only have one possible charge. So not the multivalent ones that you see throughout the transition metal section of the periodic table, but we're talking about metals that are in like groups 1 and 2, for example. They're always +1, always +2. If you're looking for its number to use, just look up the ionic charge on the periodic table. So in sodium chloride, the sodium is +1. Calcium oxide, the calcium is +2. So strictly from the table. Now, if there are any other elements other than what I've just summarized in this table, you have to solve them. So multivalent metals, you have to solve, given the stuff that you know for sure, and any non-metals other than oxygen and hydrogen, you have to solve. So we'll do a couple of examples of this. So solving oxidation numbers, because the reason we're doing this is to figure out if something has gained or lost electrons. We need to know its numbers first to be able to see if it has increased or decreased. So you write down the numbers you know. You multiply by the number of atoms in the molecule, because we're trying to come up with an entire molecule whose sum is 0 possibly, like this would add up to 0 like all molecules do. Or if it has an existing charge, like the sulfate ion, we have to add up to that charge. So we always know hydrogen, we always know oxygen, so the only thing we'd possibly be solving for in carbonic acid would be what is carbon's oxidation number. So to do that, we're going to start off by writing down that we've got 2 hydrogens plus a carbon plus 3 oxygens, and that has to add up to 0. So then we can put in the actual charges that we know. Hydrogen is always +1. Carbon is our mystery. Oxygen is always -2, equaling 0. So we've got 2 plus carbon subtract 6 is 0. And then 2 plus -6 is -4. So carbon subtract 4 is 0. So then if we want to get carbon all by itself, we're going to add 4 to both sides. So carbon is +4. So then you would write it like that. So that is the oxidation number of carbon. So that is how you solve it when you have a neutral molecule. But sometimes you have these polyatomic ions, and in this case the sum has to add up to that overall charge. So we're going to set it up the same way. So we've got sulfur plus 4 oxygens has to add up to -2. Okay, sulfur plus 4 times -2, because remember, oxygen is always going to be -2 for our purposes. So sulfur subtract 8 is -2. To get rid of the 8, we're going to add it to both sides. So sulfur is plus 6. Okay, so that's weird because you've been used to looking up sulfur on the periodic table and using -2 for years when sulfur is in an ionic compound. But if it's in something molecular, it can be quite different. And sulfur is not always plus 6. It depends what compound it is in, what it's going to have as its charge. So I have 3 questions here for you to practice, and then at the end of this note, I do have the answers there for you to check before you do your quiz. And of course, if you have any problems, you can give me a call. Now, if you're given a reaction, not every reaction is a redox reaction. So you may be asked to determine is it a redox reaction? So in that case, you have to figure out, did something's oxidation number change? Because unless something had a change in oxidation number, then there wouldn't have been any exchange of electrons. And if there's no exchange of electrons, it's not a redox reaction. So for the entire reaction, it's like we're going to do a whole bunch of those mini questions that I just demonstrated 2 of for you. And then we're going to figure out what substance may be oxidized and which one may be reduced. And then we can say it is in a redox reaction. Okay, now just on a note, we have done total and net ionic equations earlier, and spectator ions, remember, literally don't do anything. They're just hanging out before, hanging out after, don't participate. And now we're going to revisit those because we'll see that if something has an oxidation number that doesn't change, then you can assume that it was just a spectator. Okay, now these 2 questions here are what you're going to do. What I want to do for the examples are actually the ones that are back in the front page. Okay, so we're going to scroll back to the front page, and then these 2 will be your practice questions later, and there's the answers. Where are we here? There we go. Okay, so we're going to label all the oxidation numbers. So aluminum is a pure element, so that's going to be 0. Okay. For copper chloride, you're going to, you could look up chlorine on the periodic table, see that it's -1. And in that case, because there are 2 chlorines, copper could be +1 or +2. But you can tell that it must be +2. You can also do reverse crisscross to figure these out if it's ionic. Okay, so you're just figuring out the charge. Here, copper is 0. And here, again, we could do reverse crisscross and realize that aluminum is +3, plus it's monoatomic, so you can just look that up. Chlorine has to be -1 for this molecule to add up to 0. Okay, so then we're looking for something that has changed. So here's aluminum. It went from 0 to +3. So it had an increase in its oxidation number. So, oops, that's super messy. 0 to +3. So therefore, aluminum was oxidized. Okay. So if you increase your oxidation number, you must have lost some of your negative electrons. So think of Leo, loss of electrons is oxidation. Okay, copper also had a change happen. Okay, so copper went from +2 down to 0. So copper was reduced, because literally the oxidation number was reduced. Okay, and then if you notice, chlorine -1, chlorine -1. So chlorine was a spectator. Okay, but as long as you have something oxidized and something reduced, this is definitely an oxidation or a redox reaction. Okay, so this is a redox reaction. And again, like I said before, you won't have one without the other because the electrons that are lost have to go somewhere. Okay, we'll check out this one here. Where iron is reacting with oxygen to make rust. So all corrosion is redox reaction. So again, we've got pure element, 0, pure element, 0. Here, oxygen is -2, so we could actually work this one out just because it's a little more complicated. So we've got 2 iron plus 3 oxygens have to add up to 0. So 2 iron plus 3 times -2, because oxygen is always -2. 2 iron subtract 6 is 0. 2 iron equals +6, or iron is +3. Okay, so let's throw that in here. That's an example of a metal that can have more than one charge that you would have to work out occasionally. All right, so once again, iron went from 0 up to +3, so iron was oxidized. Okay, and then oxygen, oh, I should have labeled that. It's -2, always -2. So it went from 0 to -2. Therefore, oxygen was reduced. Okay, that is all for today. Hopefully you found that kind of review a little bit. And don't forget to practice these 3 questions here where you're just solving for one mystery substance. And then I have summarized the steps for figuring out if it's a redox reaction. And you have 2 questions here that you'll have to solve every single number and do what I just did where you're labeling who was oxidized and who was reduced. Okay, good luck.